Hey guys, and welcome to question FM245 of the Further Maths Fortify study guide. This question reads, a small city is divided into 4 quadrants, Alpha, Beta, Charlie, and Delta. The number of Jans, the number of Michaels, and the number of Vincents living in each of the quadrants in 2018 is shown in matrix R below. And then we're given this matrix here, matrix R. Question A asks us to write down the order of matrix R. Now looking at this, we can see that it's 4 rows by 3 columns. So this is a 4 by 3 matrix. B then says, how many Michaels live in quadrant Charlie in 2018? So we're looking for Michaels in quadrant Charlie, so we're looking at the 3rd row, 2nd column here, which tells us that we've got 500 Michaels living in quadrant Charlie. Question C then says, in terms of quadrant alpha, what does the sum of elements in the first row of matrix R represent? Now that word sum there means that we're adding the elements together. So we're looking at these 3 elements in our first row. What is represented when we add them all together? Well, that would be the number of Jans, Michaels, and Vincents living in quadrant alpha in 2018. We're then given a little bit more information. We're told that a survey is to be held in the city. All of the Jans, Michaels, and Vincents will be asked if they are happy with their name or would prefer another name. It is believed that 35% of Jans will be happy with their names, 15% of Michaels will be happy with their names, and 50% of Vincents will be happy with their names. The information is shown in matrix M below, and then we're given this matrix here. Question D then says, explain in terms of rows and columns why the matrix product R times M is defined. So if we were to look at R times M, and I'm just going to put it up here, what we would see is that we've got a 4 by 3 matrix being multiplied with a 3 by 1 matrix. So we know that this is defined because the number of columns in our first matrix, matrix R, is equal to the number of rows in our second matrix, matrix M. So that's pretty much exactly how we'll communicate this. So question D, our answer would be the number of columns in matrix R is equal to the number of rows in matrix M. Cool. So that's A through D complete. Now looking at the next little bit of information, we're told that the product of matrices R and M is shown below. Now I'm not going to write out the full version there, but we'll do a little summary, which is R times M equals X, 434, 447.5, and 422. So question E says, using appropriate elements from the matrix product R times M, write a calculation to show that the value of X is 439. So we're being told that X is 439, however, we have to show how it's 439. So this is our matrix product. And in our matrix product, the element x is in the first row, first column of our answer. So if we take the elements from the first row of R, which is the first matrix in our matrix product, so if we take the first row and combine that with the first column of our second matrix, we will get the element that is in the first row, first column of our matrix product. What this means is we take these three elements, the 390, 450, and 470, turn them on a 90-degree angle clockwise, and then multiply them with each of the elements in matrix M and add those products together. So what we have is 390 times 0.35 plus 450 times 0.15 plus 470 times 0.50, which once calculated in your calculator should give you an answer of 439. So this is the calculation to show x equaling 439. Question F then says, in this small city, how many Jans, Michaels, and Vincents are happy with their names? Give your answer correct to the nearest whole person. So guys, this takes a little bit of understanding of, in terms of what these matrices are doing. Here we have the number of Jans, Michaels, and Vincents in each of the quadrants. So this is just the total number. This matrix here, however, is the percentage of each of the Jans, Michaels, and Vincents that are expected to be happy with their name so far. So our product, once we combine these two matrices, is actually the number of Jans, Michaels, and this first element, element x, which is 439, would be the number of Jans, Michaels, and Vincents in quadrant A who were happy with their name. And then 434 would be the number of Jans, Michaels, and Vincents in quadrant B that were happy with their name. And so on and so forth for both Alpha, Beta, Charlie, and Delta. So in order to figure out the total number of Jans, Michaels, and Vincents that are happy with their names, we simply sum all of the elements from this matrix product. So what we get is 439 plus 434 plus 447.5 plus 422, which would equal 1,742.5. However, now we have to round this to the nearest whole person. So our answer is going to be 1,743 Jans, Michaels, and Vincents are happy with their names. So there it is, guys. If you have any questions for us, please leave them in the comments below. Otherwise, I'll see you in the next video.